So we're now ready for the second part of the lecture. So far we have discussed the records and how the records are secured, and how, in particular, very critically, we have the ability to make sure that the right people can change records only. So this is the authority part that I had discussed in the last lecture. Now what we have to figure out is, how does a network of computers without a central authority that makes any decisions, how do they agree upon an updating of records? So in other words, there's a transaction that you make. How is it actually entered into the database? How's that done? Now that sounds like a trivial task, but if you think about this, it's actually pretty difficult, right? Because any of these computers that you see there on the screen could be the one that initiates the transactions. How do you know which one it is? How do you know whether or not that computer actually can make those changes? How can you be sure that the other computers accept it? What is the mechanism that creates consensus about the updating of records? And that's what we're trying to understand now. Now, to understand that, we have to go back to a mathematical problem, which is from the late 1970s. Then let me illustrate what the problem here is that we could see. So we go back to the problem that Alice would want to, make a deal with Bob. What she wants to do is she wants to buy a car from him, and she wants to pay him in a digital currency in this peer-to-peer network. Now, the way we discussed it before is that the transaction will be signed, and then it goes to the verification protocol, and then we go from there. Now, the problem is that at the same time as she makes that payment and makes that deal with with Bob, she can also make a deal with Charles, buy another car, and essentially spend the same amount of money twice. And can she do that? Is that possible for her? Well, if you think about this decentralized network of computers, if she puts in the information, for instance, at two different nodes, and they try to update at the same time, it has to have some rule to agree which transaction actually should go through and which shouldn't. And so here, the problem that we're trying to address is basically that Alice here has the ability, or we want to prevent her from having the ability to spend the same money twice. That's the so-called double spending problem, right? So we need to order the transactions. We want to make sure, which one goes first. And we also want to know when is it actually in the database. So these are not trivial problems to solve. And in order to do this, we have to go to a mathematical problem, as I said, that was around since the 1970s.